All right, so this is a session on Kubernetes, cheap and simple. I call it the Raspberry Pi a la Micro K8s. So as we'll kind of cover during the presentation, Raspberry Pi is just it's a quick and dirty way to implement Kubernetes. You can go in the cloud. There's, that's definitely an option. Obviously, there's a bunch of different platforms you can go with. If you want to go AWS, if you want to go Microsoft, if you want to go host your own in the cloud somewhere on a platform as a service, or go with Google, or something like that. Those are all different operations or different options that you have at your disposal. Mine, when I went down this path, was mainly out of one curiosity, because I'm kind of a Raspberry Pi enthusiast. I really just like this whole concept of a computer the size of a credit card that has, 8, 9, 10 times the processing power of something that they use to put on a space shuttle. I like the concept that there's a large community of different projects out there that are available for it, that you can tinker around with it and put, if you get bored with one project, you can blow it away and put on a completely different one. And it's just very easy, very simple. And the cost point is very easy, because if even the most high-end Raspberry Pi that's out there sells for $64, I think it is $65 was the latest price on it. So it's really cheap to get into, and they're pretty responsive. So what is it? So like I said, Raspberry Pi, it's a low-cost credit card sized computer. There's multiple versions of it, which that's why I was saying, the price points kind of are as much as you want. So they have, they call them zeros, which zeros, if you imagine this being the regular, a zero is literally half. And so it's half of a credit card size computer, and it has comparable capabilities. There's some limitations. It doesn't have quite the expansion possibilities as the other ones, but what it lacks in functionality, it makes up with in size. So you can get it in a lot smaller form factor. So you can do, actually, we used to have one, which is kind of nice that I'm sitting here at my desk, I guess, but I should have had it out before all this started. Well, there it is. So this is good. Can people see this? Yeah, so it's just a little guy, but it has a lot of the same functionality. It has, it's still single board computer, so it's not like you're, you don't have to have a case or anything for it. But yeah, so the zero is the smallest, and then they make a zero that has wireless and a zero that doesn't have wireless. They have Bluetooth, and then they have they call it a 1, and so the 1 comes in model A plus and B plus. It was kind of that was the first model that most people are familiar with, because it came out and it had, it was the one that they kind of made famous. They were made famous for because they started making them for primarily for education. So they would take it to small schools. The project originated out of England. So they were taking these computers to Africa, Asia, a lot of underdeveloped nations, so that they could get them in, and you wouldn't have to spend a whole bunch of money, and you could do a whole bunch of them at once, because you could just pack them in a box. You didn't have to have these large monitors and everything. And when they originally came out, they had composite video, and they had what was the other one? Oh, they had HDMI. And the composite video is strictly there for lower technology groups, that they only had access to like a TV. So, and even the Raspberry Pis that are out today, they still have composite. They've just kind of reworked how you access the composite. So it's not like you're seeing the same barrel connector on the side. It's more of it's the 1/4-inch jack. So A lot of different changes. So yeah, so then the Model 2B came out, and the Model 2 moved up. You know, each iteration kind of added more features, just like theory. You know, the computer theory goes. I mean, it doubles every year. So you've got all of these models increase processor power. They increase the RAM that's included. It's starting with the Model 4 is when they started adding on USB USB 3, and then they also changed out some of the graphics. So as you can see here, the USB 4 actually has dual video, so you can actually do dual HDMI, and they do, if I remember correctly, they do 4K video, so dual 4K video off a single board computer, and then they switched out the power supply. So the power supply previously was a micro USB, and they moved to a USB-C for the increased power. So there was more power requirement and everything on it. And then they also, I think it was starting with the 3, they moved to a micro SD card instead of using the full width standard SD card. They also have a Pi 400, which is essentially, it's a Model 4 Raspberry Pi that's it's mounted inside it looks like a glorified keyboard, and essentially it just has the keyboard already there for you, and all you have to do is hook up a mouse and a monitor, and you've got a working computer. And then the last one there that I mentioned is they call it a CM4, and CM4 stands for compute module, because again, it's a Model 4, but it's actually developed for industrial applications. So you can actually get it looks like a daughter board, almost like what you'd put like a RAM slot into, where you'd stick it in and then you'd push it down. It does the same thing, only it does it with a Raspberry Pi. So you can have multiple Raspberry Pis in an enclosure, again, for industrial applications. So if you're doing I've seen projects out there for, what do they call them? The 3D printers. I've seen them for like automation. So if you're setting up like laser cutters, robotic arms, and conveyor belt lines, like automated systems like that in a factory, they have these types of things made for them. The latest one you can get in with 2, 4, or 8 gigs of RAM. Again, it comes with HDMI and composite video. The Raspberry Pi 4 and the 3s both had 4 USB ports, but the 3 only had 10100, or I'm sorry, the 3 only had USB 2, but the 4 has 2 USB 2.0 ports, and then it has 2 USB 3.0 ports. And then the USB 3 has a 10100 NIC, and the USB 4 has a 10100 1000 gigabit NIC. So they finally stepped up that on the USB, or on the Raspberry Pi 4 to get the gig NICs on it. All of these have what are called GPIO, which is blown out here on the right-hand side. GPIO is just it's a general purpose input-output bus. So they give you all of these different ports, and this graphic kind of labels all of the different pins and what they're used for. But essentially it comes down to pulse wave modulation, I2C ports, UART, 5-volt in, and then there's other purposes that they have on here that you can use for them as well. But the standard ones that you see a lot in the projects are kind of fall into these 4 categories for most of them, just based on what you're trying to control or what you're trying to import, input, or whatever your project's trying to do. And then it also comes with a display port, which you can see here, and then a camera port, which is located here. Both of these are proprietary. So the display port, not to be confused with display port like the monitors. This is a display port it's made for LCD screens, so you can actually have, again, this is just weird timing because I did not have this planned, but you can actually get an LCD monitor that you can actually plug a Raspberry Pi into the back, and it has a little cable here, and that goes right into that 0 insertion force plug. And then they also have a camera that, again, the same thing. They make a camera that you can plug into that port right there, and you can now have a webcam. It's actually I think they just came out with a new version of it. It's a high-powered telephoto lens, so you can get pretty decent zoom on it for like outside. I've seen people make game cameras with them, like for hunting. So just a lot of stuff all put on one chip, or all on one board, that you don't have to hunt down a bunch of different computer parts for it. And you don't have to have a big case or anything for it as well. So, so the next continued I have on here is, what is micro K8s? So if you know what K8s are, which is just the short term for Kubernetes, micro K8s is just a bundling of Kubernetes, a distribution of it that is slimmed down so that it can run on or I shouldn't even say low power devices. It's just a minimalistic version of it. So instead of having tons of packages that are put on top of it, it's the core pieces that it needs to run to do Kubernetes. And then if you want to add on packages, as we'll see during the demonstration, you can add and install whatever you want. Low ops, minimal production Kubernetes implementation. Like it says, it's for devs, it's for clouds, it's for clusters, workstations, edge, and Internet of Things. So it really, it started out as a project for developers, like that you'd use for DevOps, that you'd use for something, just as a proof of concept or something like that. But then people started building on all of these projects and really hardening the packages so that it was just as resilient as putting it on bare metal, high powered computers. So you can now run a very reliable system on a Raspberry Pi, or because you can put micro K8s. Micro K8s runs on Ubuntu, so you can put that on anything that runs Ubuntu. You can put it on a Dell, you can put it on a Mac, you can put it on anything you're thinking of, as long as it can run Ubuntu. So hardware requirements for what I'm talking about. So I'm not going to get into the huge details of like all the different specs that you have to have for running all these different software packages and things like that. But what I have is, so what's kind of required is obviously a Raspberry Pi. I chose the Model 4 just because doing research into all the different packages and things like that, the Model 4 really has enough horsepower that it makes sense. I have run it on a Model 3 as well. It's just a little bit more sluggish, especially when you start getting into loading multiple Docker images, or dealing with anything that has any sort of load to it, like if you're having throughput for switching or any sort of network traffic. The Model 3 it has a hard time. It'll do it, but you'll notice some lag. Obviously, you need an Ethernet cable. You'll need a 5-volt that runs at 3 amp USB-C power adapter. I actually get by sometimes with just using, I have these little barrel converters that convert a micro USB to a USB-C plug, and it seems to work pretty good as long as you have the 3 amps. That's the biggest deal. Is the previous Model 3s and Model 2s would run on 2.5 amp, but the Model 4 needs 3 amp, and so it takes a little bit more juice. You have to have more power throughput, so it needs that 3 amp. So it's kind of picky on that. The micro SD 3 card, I have 32 gigs is what I prefer. Again, when you start going out and shopping, anything less than 32 gigs at this point is you can get them, but you could spend the same amount of money and get a 32 gig card, or you could probably get a 64 gig card nowadays, just based on how it's going. But the ones I'm using are all 32 gigs just because it was easier and I had them on hand. I have down optional a second Raspberry Pi. So a cluster technically is multiple computers, obviously, but with the way micro K8s works, or just Kubernetes in general, you don't need to have two two nodes to make the cluster. You can have a one node cluster and you're just going to have all of your Dockers are just going to run on one node. If you have multiple Pis, multiple nodes, you can then spread out your Docker images across different across those nodes, which makes it spread out that load better. You may need a network switch. Again, depending on how many Pis you're using, you're going to need enough ports on your router, your switch to facilitate both all the devices. Again, you're preferably going to want 1 gig just because the faster ports are going to give you better downloads when you're running your upgrade or running updates and things like that. And then also, most of the stuff that you run on Kubernetes is headless. So all of your stuff is going to be going through that equipment. It's going to be going through that network. So if you overload that switch, you're going to start dealing with a lot of lag. And then I put down optional for monitor and keyboard because as you'll see once we start getting through this stuff, again, most of it's headless. So you have to get a lot more comfortable with doing things on the command line, doing things via SSH, and doing less things with a GUI interface. So yeah. So on the next one, so software requirements. So I have down here Ubuntu 20.04.2. You can run 20.04, just the plain version of it as well. I'm just using 20.04.2 because it's the latest for LTS, for long term for Ubuntu. So I tried using 21.04, but it's too new. So Micro K8s I think needs a little polishing to get their software to work with some of the newer standards that are in 21.04. So you'll see that. Micro K8s, I can't remember the version that I'm running, but I'm running latest. So I think it's like 1.20, if I remember correctly. Because I'm on Windows, I use Disk Image Writer. The disk image writer I use is Win32 Disk Imager. It is a disk image writer. Macs have their own version. Linux, they have a DD command, which is the same thing. It allows you to write raw to a card. But you'll need that kind of software to write to the cards to get the images that you download for Ubuntu written onto them. You'll need a terminal client. I use PuTTY, and then I also use a utility called mPuTTY. mPuTTY is just a multiple window version of PuTTY, so you can run tabs of PuTTY rather than just having one instance of PuTTY running across and you have to hunt stuff down. And then I put down an SCP client, and my preference is WinSCP because I'm on a Windows machine. SCP is just a fast, easy way for using SSH to transfer files to and from your Raspberry Pi, so that you can easily use a USB drive and plug it in, mount it, and do all that kind of stuff. But once you kind of get comfortable with command line and using SSH and using PuTTY, it's a lot quicker just to be able to issue commands and copy stuff directly to it that way. So. I kind of touched on some of these things. What else can you do besides Micro K8s? You can do RetroPies, things I've done. So RetroPie is a platform where you can install emulation software to run old school video games from like Nintendo and Sony, Sega and PlayStation. So I've had that going. I've used OpenHab, which is an home automation software. So I have a security system on my house that all runs off a Raspberry Pi that I can open or I can turn off and on lights and lock doors and do all that kind of stuff without having to buy a specific hardware or a specific contract with a security company. Open Sprinkler Pi is a sprinkler system. I have my entire sprinkler system runs on a Raspberry Pi, so I have a UI for it, and I can turn on sprinklers and have a bunch of programs going for how I want it to water, and it goes off it goes off a weather station, so it adjusts the watering based on the weather and the day of the week and all kinds of stuff. I have Pi-hole, which is a DNS ad blocking software that runs on a Pi, so it can do DNS querying, local DNS, and then it can also block pop-up ads and stuff like that for your entire house, because it'll do filtering across your entire network as like in real time as you're surfing to suppress ads. Plex, I use a video platform for sharing movies and videos and music. And it's called Plex, and you can install that on a Pi, and it can be a client to pull down audio. A dynamic DNS updater. So if you're familiar with networking and dynamic DNS, you can use a Raspberry Pi to update your public IP address to internal resources, like on a Raspberry Pi cluster. And then I've also done a do-it-yourself Bluetooth speaker system using what's called a Hi-Fi Berry Hat, which is this. It's just an add-on, and again, it uses those GPIO ports, and so you can plug that right into the GPIO ports, and now all of a sudden you have it's essentially a sound card for the Raspberry Pi. And then just to show you a picture, so this is the Raspberry Pi cluster that I actually built. That it's technically a 7-node cluster with a master. So this is my master right here. And then I've got 7 Raspberry Pis mounted here. Actually, 1, 2, 3, 4, 5. This is a bad picture. I actually added 2 more on the end. So there's 7 clusters here. And then I put it in an old Dell computer case that I had during the pandemic. And I built a bunch of this stuff inside to mount hardware stuff onto, and a power bus down here to get the 5-volt off of the computer power supply and everything. So it's very powerful, and like you can make it as big or as small as you want. If you go online, there's actually guys out there that go through contests to see who can build the biggest Raspberry Pi cluster. They'll have like these monstrous freestanding display cases that have hundreds of them all wired up and running Raspberry Pis off of them. So I'm not by any means saying this is the limit, because there's way more you can stuff in there, but yeah. So that's what I did during the pandemic. So the first step that you have with putting all this stuff together is that you have to burn the images. The way that I kind of set this up, just for sake of time, was I already burned the images, because to download the images and burn them takes a little bit of time. So it's just easier to kind of deal with that yourself, or deal with it before we got ahead of this. So one of the cool things with the Raspberry Pis is that, like it said there, so for headless installs, make sure to put the SSH file in the boot partition of the card. So when you burn the card, there's 2 partitions on the SD card. There's the Linux partition that Ubuntu boots off of, and then there's the boot partition, is what it's called. And the boot partition is written in a FAT file system. So you can see it on Windows, you can see it on Linux, you can see it on a Mac. And if you literally just put a file in the boot partition, the file is just named SSH, and that's it, that file triggers on the first boot. When the Raspberry Pi comes up, it enables SSH. And that's the easiest way to do it, because then you don't have to have the monitor, you don't have to have a keyboard and mouse. You can just instantly have SSH access to it, as long as you know the default password for Ubuntu, which is just Ubuntu. So username, password, pretty easy. And then you have to know the IP address, which is the second bullet point there. So because I always think that's kind of the annoying thing about the Raspberry Pi, is that, like, if you bought a networking card and you took it out of the box and you looked at the network card, you could physically see on the network card what the MAC address is for the network card. On the Raspberry Pi, they don't anywhere on that card print what the MAC address is for it. The only thing you can go off of is that all Raspberry Pi network cards have the same manufacturer ID at the beginning. So they'll all start with the same first 9 letters are all the same. It's like DC 9 something. So you can use software. It's literally called Advanced IP Scanner, free tool. All it'll do is you tell it your subnet, so 192.168.1.1 through 254. It'll scan your entire network and then tell you what hosts are on your network. So you can scan it and then just find the one that has the Raspberry Pi MAC address on it and do it that way. again, so because I have done this a lot, I actually go the next step further, and I'll actually go in and I hard code the IP addresses or the MAC addresses so that the MACs always resolve to the same IP address. And then you'll also see in the the demonstration as I work through it, you'll see I actually go another step further, and I also assign a static IP address on the Raspberry Pi just to make sure that for some odd reason that if my router doesn't honor the MAC address, that it still assigns the IP address correctly. The other thing that I did that I'm not going to demonstrate is updating the software after the initial boot. So again, that's another long portion of this, is just running update and then the dist upgrade, because it just takes forever to download all the packages depending on how old your distribution is. But yeah, so it's just running the sudo app update and then sudo app dist upgrade, and that just downloads all the latest fixes and patches for any software package that's on your Raspberry Pi after you burn the image. And then the first thing I'll do then also is that I'll set the host name, just because I like to be able to, when I'm connected to the SSH sessions for the Raspberry Pi, as long as you have the host name set, you can easily tell the difference when you've logged into them, which Raspberry Pi is what. Because once you start dealing with 6, 7, 8 different Raspberry Pis all in the cluster, you want to know which one is which, so you're not going back and forth trying to, looking at IP address or something like that. So the next part of the what I call continuation of the first phase is, again, setting those static IP addresses. So you'll see that I've already taken care of this, but it's just assigning static IPs using the net plan, because that's what Ubuntu uses for IP addressing. So all you have to do is update this YAML file with something that looks very similar to this layout. It's YAML, so it's not exactly like this, because YAML, and we'll talk about this in a little bit on what the nuances with YAML are, but there's a lot of indentations that have to be taken into account, but you can easily assign them once you get in. You just have to make sure to get it done. So the next, for the last part of the first phase is I also update the hosts file, which again just allows for the 127.00 or 0.01 with your node name to resolve. So again, you don't have to do this. I just prefer to do it for the cases where I type in the host name and I want to hit my host, rather than having to type in an IP address for a loopback. So, and then the last one is updating the command line.txt. This one is, you'll only see this with dealing with Raspberry Pis for micro K8s, because it's a specific set of features that have to be enabled on Raspberry Pi to run micro K8s. So it's the C group enable, the C group C group enable CPU set, C group enable memory, and C group _ memory 1. They're just different features that allow the memory assignment to be more native for micro K8s, so that it works correctly for it. So once you've done all of that, then you can reboot, because at that point you've done, that's pretty much where I'm starting off with the Raspberry Pis I have sitting here at my desk. So the second phase is going to be installing the micro K8s. So I'm gonna quick pause this. Let's see. I'm going to end. And then I'm going to bring up what I have. So like I said, this is just PuTTY, but it's multi-tab, so I don't have to have two windows. I can just go between the two. And you can see I have these are all my different Raspberry Pi devices over here. This is my cluster over here.
Hey, Adam, we're not seeing your screen.
Yeah.
Oh, I will get that shared. Sorry. Thank you.
We were just seeing you out in a tent someplace. We thought you maybe had checked out.
Let's see, so I want screen 2. Are you guys seeing my screen now?
Yep.
Okay. So yeah, so it has folders over here. So this is like my cluster. So I can save each one of mine. So I can easily get, like, I can easily just double click and now I'm in my cluster. So I don't have to memorize IP addresses. I don't have to do any of that stuff. So, but as you can see, I have demo 1 and demo 2. And those are just the 2 Raspberry Pis I'm going to have in my cluster. So I've named them. And like I said, so because I changed the host name, I can see the host name here in the login. So or in the command line, so I can easily identify it. And this is just what it looks like when you first log into the boxes after you've done a clean reboot. They do a cool little thing where they put the little message on here, really, pushing micro K8. So that's kind of where I kind of got introduced to this. I was like, well, maybe I could start doing that. So that's where I kind of got into this. So, so from there, I have all my notes here so I don't have to type so much during this. One of the things that I also did, and it was, it's completely optional, but if you're running a cluster, you have to figure out a way to deal with shared storage. However you do that, that's up to you. There's a ton of different options. I personally have it's called TrueNAS. It used to be called FreeNAS, file server that's down in my basement that serves up NFS shares, so I can mount that. So if I go to mount storage 1, this is just it's a shared drive that's on my file server. But whatever that is, that's what you need to do. And the reason you have that is, we'll kind of get into this later, is you have to have persistent storage, because if one node goes down and it moves over to a different node, it needs to know where it needs to know where the system files are, where the image is loaded, where all this stuff is occurring. So it fails over. It can move from one node to the other, but it needs to have that shared storage to be there at all times. So I've seen different people that'll do it with physical storage. So they'll have like a shared USB hub they can all mount. I've seen other ones where they'll do different, like they'll buy like just off the shelf, like Western Digital MyBooks that have a webinar, have like a NAS functionality where you can connect multiple devices to them on a network. But you have to think of that. So that's one of the things I didn't really mention in the pre-setup that I did, but I did it because I need to do it for the demo. But you don't technically have to do it, especially if you only have one node. You can, on a one node cluster, it's only got one node to go to, so you can use local storage for that. But you can't use local storage for a multi-node cluster when it has to move the files between the physical SD cards like that. So yeah, so the first step, like it said, we need to install micro K8. So I'm gonna run this and then wait. But the command is pretty simple. It uses the snap plugin, or the snap repository system to install micro K8. So it's literally sudo snap install micro K8s, classic, just to use the original version. And then I specify the channel on there just to make sure that especially for the demo, I want to make sure that they don't accidentally, update the micro K8s to a version that won't run on Ubuntu and won't run on it won't run on a Raspberry Pi. So this one takes a little bit. I wanted to, I struggled whether I would not show this and just do it ahead of time, but I wanted to show it just because it's kind of a trickier command. It's not like just running an update or anything like that. You want to have a little bit of an understanding to it. Plus there's some other things that we do right after this that'll, that makes sense, that take up time as well. So, but yeah, I guess while we're talking about this, so one of the other things that to take into account, I kind of already mentioned the Ubuntu 20.04.2 and the 2104. So, and I have this as a follow-up slide at the very end, but when you're running things in Kubernetes and you're running things in Raspberry Pi, it's very important that you're very familiar with, it's a code, like when you're dealing with Git and you're using source control called tags. they use tags all the time in Kubernetes and Docker in general. And it's just a way for them to split out images without having to come up with a completely different file system. So you can, but the main point is that there are different tags for different chipsets. So the main ones that I generally deal with, and probably most people deal with, are AMD 64, ARM, it'd be, well, ARM v7, ARM v8, and then ARM HF. And they all have different, like the ARM 64 is anything 64-bit. So Intel, AMD, it all goes by AMD 64. ARM has 3 different flavors. You can see, you'll see ARM 7, you'll see ARM 7 and ARM HF kind of used ubiquitously or ambiguously, because they're really the same thing. They're just denoting that it's a 32-bit Raspberry Pi, because ARM is the architecture that Raspberry Pi uses. ARM v8 is the 64-bit chipset that that the Raspberry Pi 4 uses. So you'll see a lot of those things show up when on a lot of projects now, because most people are, they may do an ARM HF, they are more likely to do an ARM 7, and then they are very likely to do an ARM 8 just because it's so prevalent. But so that's always a good thing to note, and we'll get it, like I said, we'll get into some of those details. So the next one I do here, this is just I'm modifying the user that micro K8s runs at so that I can run commands as it. And then I also run another command here to take ownership of files in there, so that, again, so that my user can use it easily. So I don't have to put sudo in front of everything. And then the last thing I have to do once I've modified my user is I have to reinitiate my connection so it refreshes my permissions. So I'll relog in. And then, so this is something that I learned. So some of the stuff, some of the material, and I have these resources at the end of my slide deck, is there's tutorials. Like, you can literally find tutorials on how to do this stuff that I did. It was not there when I originally did it. They have revamped the tutorials now. So almost everything I've done is in the tutorial. The one thing that they don't include, and I'm not really sure why, if it's not new enough for them yet, is that for some reason or another, micro K8s, when it's running on a Raspberry Pi, does not support the new micro K8s high availability clustering. When they first came out with micro K8s, they used etcd and flannelD, which are 2 software packages that deal with failover, not necessarily high availability, but failover. And then I want to say it was like early 2020, they came out with a new version. I think it was 1.19 of micro K8s, and they started supporting an HA cluster, which allowed you to not have a dedicated master. You could have, everything could just be a node, and it would just, you would just shift resources amongst all the nodes, which is great. The problem is that for whatever reason, whenever they built that, it uses up so much resources that the Raspberry Pis won't even stay stable. They just crash all the time. It'll start up, but then it'll instantly crash, either because of the power consumption or just stability on the core. It just doesn't maintain it. So you have to do this command, which is sudo micro K8s disable HA cluster, and then they even had to go, like when I had to figure this out, it used to not require the force command. Now you have to actually tell it, yes, I really, really mean that I want to disable this. So you have to run force. And this takes a little bit to run too, but what this ends up doing is it disables HA and then reverts it back to using the flannelD and etcd instead. And at that point, the only real, at least the only noticeable difference I've had is, 1, it actually works, and 2, it allows you, you have to have a master node. So you have to have a dedicated master, and then however many child nodes that you want in the cluster. But you can run Docker containers off of your master. It's just not a recommended recommended way to run, because really your master has enough work on its plate normally anyway, that it's doing all the negotiating of resources and tracking and all that stuff that you don't want to, but it'll work. It just isn't ideal. So yeah, this is like this part is probably the last of the long running processes that takes up time. So yeah, it's just doing so much with taking out all of, uninstalling something and then downloading the packages and the dependencies for the new stuff that has to go back in place. And I wish they'd give you a way, like if they'd give you a way to say on the install that you didn't want it enabled, but they don't have a way to tell it. Like there's not an argument in here to say what packages you want enabled from startup. They just install a default and then you have to go back and disable the stuff you want and enable the things that you do want. So yeah. And luckily you only have to do this on your master. So if you set up multiple nodes, you don't have, like when you install the micro K8s, when you install, or when you have the nodes join the master is what dictates what packages it installs and what things need to be there, and it just links them up, that you don't have to deal with it. So that's a nice part about it. Yeah. Did anybody have any questions while while we wait for this? If there's anything you had interest in or questions about? Or how many of you, I guess, how many of you guys have actually used a Raspberry Pi before?
I've used one, I think it was about 3-4 years ago since I used it though. Got it up and running, tried to use the camera, and the camera that I had, I could not get resolution out of it. So,
so yeah, so I had one of these laying over. So this is a Raspberry Pi 4. That's an older one, but again, it looks almost identical to, or I'm sorry, this is a 2, not a 4. This is a 2. I have a little case for it, but it looks very similar. They try to keep their footprint the same so that they can, like when you buy cases, you can move them from case to case. But like I said, this one, it just has it has 4 USB 2 ports instead of the 2 USB 4 or USB 3s and the USB 2s. So, and then it's still got the HDMI on the side. This has full-size HDMI, where the Raspberry Pi 4 has the micro HDMIs. But yeah, and then I think I was saying on here, so this jack right here that looks like an audio jack it is an audio jack, but you can also buy an adapter that will convert that to also output composite video. So again, you can hook it up to an old school TV. There's actually quite a few people, like that Raspberry Pi project I was talking about, where they run Nintendo emulation software on it. There's a large following that actually loves the composite output because they can hook it up to the old school monitors, and then it looks like legit, playing games on an arcade machine versus playing it on a flat screen TV. But you can do either way. It's just, it's interesting how they really maintain that, they keep things backwards compatible as possible. Like from a hardware perspective, that's just surprising, because you just don't see a lot of vendors that try to keep stuff in a hardware perspective, keeping it backwards compatible anymore. So kind of an interesting take on that. Yeah.
Yeah, mine was a version 3, I believe.
Oh.
But I don't know which flavor of 3s it was. Haven't had it out for a while. I might have to get it back out again just to see if I can do this, but it might not have enough power to do it.
Yeah, like I said, the 3s are a little slow, but they can still do it. I mean, it's a good way to do a proof of concept, and then if you want to spend the extra money and get a Pi 4, or you can definitely do it. I know. I'm not sure when. Like they've kind of. I think they've said that they were. Now that they're putting a hold on coming out with the new version 5 of the Raspberry Pi, but a lot of people, once they said that they had people were really holding out for the gig internet. They were just struggling with why they couldn't come out with a gig internet port on here for the longest time, because it's been a standard for so long, and then to not do it. But there were different, because I think there was cost, because it wasn't just the port, because obviously the port's the same size, but the back end for all the tunneling and channels, like the data channels for the network card, was just more than what they wanted to spend on it at the time, and now they finally got it. So yeah.
Do you know on the 4 you were talking about that video camera output? Does it output 1080p in over HDMI?
The new one that they came out with, I think actually does. I can't remember if it does 1080 or if it does 4K, but it's a high resolution camera now. Because yeah, a lot of people have been. I've seen a lot of different stuff on forums about people switching over to it especially on the Pi 4. So
yeah, I'm kind of interested in doing something with that one, especially if I can remote control the zoom and the focus.
Yeah.
Or is it a static focus?
I know I think the zoom and the zoom is definitely not controllable because it's a fixed lens, but I believe the focus is changeable, like digitally changeable. But yeah. So yeah, so the HA has been disabled now, so now it's running final D and etcd, just like it says on the screen. So the next thing I have to do is so we disabled HA clusters. So now I need to enable the things that I actually want. So this is the command to enable it. The things I need are, I want the dashboard module installed. I want the DNS module installed. I need Ingress installed. And I need this, it's just storage. So what this is, and I'll just hit enter because this will take a little bit, not as long though. The dashboard plugin enables a web interface dashboard for the Kubernetes cluster, so I can see my nodes, I can see my my images or my Docker containers that are running. I can see all the different resources. DNS is obviously centralized DNS for the cluster so that it can resolve names between the nodes in the cluster. I also have Ingress specified, which allows for external access to the internal cluster nodes. And then the last one, the last one there is storage. And storage is the plugin or the add-in that's used for MicroK8s to mount file systems, so that I can mount the NFS share where my stuff is going to get installed to later. So all of those packages are required, but there are other packages that I'm not installing that are also useful. They're just not necessary for my demo, and frankly I haven't used them. I know, like, you can install they have a registry, so you can run a local registry for Docker containers so that you can you don't have to always download them off a Docker Hub. You can host them locally then you don't have to pull them down every time from the internet. And it's kind of important now because during the pandemic, one of the things that Docker's Docker Hub decided to do is they started throttling people's download speeds of their images off their web service. So after you hit so many downloads or so much throughput for the day, they start throttling back your downloads, which is kind of annoying, but it really depends on how often you rebuild your stuff and how often you're pulling down images. So now those are installed. So then I'm going to do this next step. And what this does is it just adds an alias for MicroK8s. When you start typing stuff out all the time and you type out Cubectl, it's a lot easier to type just Cubectl instead of microk8s.cubectl every time. So I always do that. And then my first command that I'm going to run using that is this one. And what this command does is I enabled the dashboard plugin, but there's 3 ways you can log into the dashboard well, not for the first time, but that you can log in every time. The most secured is called RBAC, which is just role-based authentication and control. It's like Active Directory. You set up users, you give them passwords, they can have roles, and they can have different permissions to do different things. For my use, I'm the only guy who runs this, so I usually just disable the login. So it's still secure. It's just based on my my admin credentials. So whatever I use to log into the cluster, rather than having all these sophisticated usernames and passwords that I'd have to do. And then the second way you can do it is you can use a token. But again, I didn't really want to mess around with tokens and all that kind of stuff either. I just wanted to be able to log into the stupid thing once I got it going. So, but to do that, you have to come into the configuration file for the dashboard plugin. And right here on the arguments for this container, you have to be a little bit ambitious and use VI for this, because they just have a VI interface, but there's a argument that you have to specify for enable skip login. And then you will see how that shows up, what that does. So that enables a thing on the screen that I'll show you here in a second. So it just finished updating that YAML file, which is, like I said, it's just a container. So it enabled a container. And then I just updated the YAML file for that container so that it would run with that flag turned on now. So now I'm going to run another command, and this command will start up the dashboard so that I can access it. So what I'll do, I'll do HTTP. And so this is the URL for my cluster. So I can see in my cluster right now that I've got demo1, because that's my master. And that's all I've got on here. If I go to my pods, I don't have any pods because I haven't installed anything, and go to deployments. It's a clean slate, but this is a complete web interface for controlling everything on that cluster now. So I can see my nodes, I can add persistent volumes, and then you can also see an overview that shows just different details for your cluster. It's kind of nice on here as this stuff goes along, and you'll see as you add on more nodes to it, you'll see like how your cores are being utilized, your memory limits, how long things have been running. You can actually come in to on a pod, you can actually see how the pod's running once we get that going. I can show you that. But yeah, oh, and so that's the next part. So now I've got my master running. So then the obvious next thing to do would be to add in my other node. So my other node, let's see. Oh boy. Maybe I won't do that, because I'm gonna have to go through all those instructions. I thought I had already done that on this, where I installed micro K8s. That's a fail on my part. I can probably get it going and then maybe show it later how you join it, because it's a very simple process. They made it like dirt easy to add a node to a cluster. So I can show you the command easy enough, but it is just this, and that's it. So once you've run this command, what it does, and I guess I can actually show what it does, but it comes back with this line of text, and this is just a CLI command. You copy this command, and then I'd go to my demo2, and I would paste that in on the demo2 node, and it's essentially the command telling the demo2 to go and find 192.168.0.190 port 25,000 and pass in that token, and then it authorizes demo2 to join the cluster. And it happens, it normally, like on a Raspberry Pi that I've had, it normally takes less than like 2 minutes for it to do it, because it has to sync up and join the cluster and, you know, do a lot of the enrollment process to make sure that the master knows all the capabilities of it and what's installed, but very easy. So, so while that's working, let me go back to the slides. So that was second phase. So third phase was setting up the shared storage, and like I said, kind of optional. You have to figure something out. However you're gonna do it, just figure it out. So I'll do that. Fourth phase, installing the add-on. So we did that. We already installed the dashboard, the DNS, the ingress, and then storage, because we needed storage. Configure the dashboard. So I already showed you how we did that. You know, just running that command and then doing the enable skip login. And then starting the proxy for the dashboard, which was just that command. Fifth phase, which is optional, like I said, is joining child nodes onto your cluster using that command. And then now let the fun begin. So this is where, like, we have a functioning cluster, like it's working. It will do what we want it to do. It's just a blank slate. So like I said in the description, I'm going to install SQL Server on it. I should have probably more correctly put a little asterisk next to SQL Server, because technically what we're going to be installing is not going to be SQL Server like Enterprise Edition or Developer Edition. It's actually what's called Azure SQL Server Edge. It's just an Edge version of SQL Server that runs on a Raspberry Pi. And the reason you have to do that is because Microsoft, in their wise judgment, has decided that they are not going to they're not going to make a Docker image that'll run on the ARM infrastructure. So you literally cannot run it on a Pi. But if you're running micro K8s and you're running it on a regular Intel machine running an AMD or an Intel 64-bit processor, you could run regular Ubuntu and install SQL Server the same way I'm going to show you how to run Azure SQL Edge. There's a very small change to how you have to between one and the other, but because Microsoft limits the frame or the stuff that it'll run on, that's what I'm left with. So so I wanted to cover some very basic concepts with Docker, just in case some folks weren't familiar with some of them. So pods are what are considered the smallest form, the smallest unit of measure in the Docker infrastructure. As far as the computing structure goes, there's different parts to them, and we'll get into that, but pods are like the smallest thing, because you run a container on a pod. You can have multiple pods. You can have multiple pods running across multiple nodes. But the pod is kind of that smallest unit of measure. So the next step up from that is a deployment. And what deployments are is that they can contain multiple pods. So you can specify in a deployment how the pods get deployed. So what order do they get deployed in? What nodes can they be installed on? What services are required for those pods to work? What persistent volumes? What storage is available to those pods? A whole bunch of different things, but that's all because deployments group together all these different things, these different attributes of your pod that are consumable by the pod. Services is the name to which Docker gave to, or I shouldn't say Docker, that's actually more of a Kubernetes thing. Services are just the way that Kubernetes exposes resources outside of Docker, or outside of Kubernetes. So you'll see that there's services for exposing ports, like web ports, to the world. So you can get in and out of the Kubernetes cluster using services, and you define your internal and external ports, kind of like you would do on a firewall. And you can actually run firewalls as an image. Like you can download Docker images that are firewalls. So Definitely, getting into a lot of the different areas of use for this. But so the next thing that we'll be using, because I have that shared storage, is persistent volumes and persistent volume claims. And this makes a lot more sense if you're a storage guy, which I don't know how many people are familiar with storage infrastructure, but and delegation of duties. So in a perfect world, if you were just dealing with a hard drive, you would plug a hard drive into your laptop and you have access to the hard drive. With the way Kubernetes works is they have, in the real world scenario, you're going to have storage, like server admins that are going to be over, like they might be over the cluster, but then you're going to have storage admins that are over just the storage devices, whether that's a NAS, a SAN, fiber, all these different storage ways you can deal with your cluster. So what they did is they divide this out into what's called a persistent volume and then a persistent volume claim. The persistent volume is what a storage admin would use because that defines the physical side of it. So it defines how am I going to get to that volume, that hard drive? How am I, like if it's a NAS, what's my path to get to the NAS? If it's fiber channel, what's my fiber channel card? What's my ports? All the different channels that it can use. All those things are specified in a persistent volume. A persistent volume claim is what the sysadmins would use to request storage on the persistent volume. So if they need to get access to a shared folder, or if they need to get access to a block device that's on that persistent volume, that's how you would get access to it from there. The next part is the secrets, and secrets are just a secure way for a Kubernetes cluster to store secrets like passwords, tokens, any sort of like secured information that you wouldn't want to give out to somebody, but people would need access to. So you'll see when you spin up like the SQL Docker container, you have to specify a password because it has to have an SA password at boot. Well, maybe you don't want to give everybody the SA password, but you can set up a secret that contains the SA password, and then they can just reference it by a name and use it in their Docker images so that not everybody has to know what the password is. And so it's just a more secure way of being able to store secret information or confidential information within the cluster without having to maintain some of their systems. So you'll see those, and those are just, that's just some concepts I wanted to cover quick. YAML is the next one. So, I kind of covered that a little bit. You can either love or you can hate YAML. YAML is simply, it just means yet another markup language. So it's a duplicitous definition for the name for the acronym. So you don't have to learn it because there are a lot of resources out on the internet that you can find that will allow you to convert JSON to YAML and YAML to JSON. The problem that I've run into is that when you get out into the real world and you start looking for resources and online stuff for Docker and for Kubernetes, people just like using YAML for it. I don't know why, they just do. I find YAML very picky just because, as it covers on the right-hand side there, it's heavy reliant on white space and indentation, so you cannot use tabs. So I'm not a big tab user anyway, but tab characters do not work with YAML. You'll get errors when it tries to parse it. It's the main sticking point for me. I don't know why I can never get over that, but it just does. As you'll see in some of the examples, so some of just very high level for YAML, a colon denotes an assignment. So if you're assigning a value to a variable, you'll use a colon. If you're trying to build an array of values or an array of objects within a YAML document, you use a dash to denote items in the array, and then you use the colon to assign those items to the array. So we'll see that. But like I said, you can love it or you can hate it, and you can use converters if you want to. I've slowly been just getting used to the fact that I have to use YAML, but yeah. So here's an example of what YAML kind of looks like. It doesn't give it justice just because the formatting looks very simple here, but you can see here, this is think of these as key value pairs, just like in JSON. So doe is a key, the value is this string of a deer, a female deer. Just that's what it is. Like that's just the value. If you queried for it, you'd find doe, return the value. Doe would be the column heading, and a deer, a female deer, would be the value for the row. This is just another example of it doing it again. This is an example of it doing it as a number, as a Boolean, as another number with a hyphen in it, just to show that you can have hyphens in a name and it knows that it's not an array value. And then you can see here, this is what an array looks like. This is the name of the array. And then these are the items in that array. And then you can see over here, this actually has an array, and then it has, these are objects within the array, not items, but an actual object with a key value pair within it. So you'll see a lot of these different uses within a YAML document when you start dealing with Docker, just because there's a lot of different ways that they store the information for, based on if it's a, you know, if you have to iterate over it, if there's multiple values, that kind of thing. So, so let's go to the demo in the document. So I, again, have typed all this stuff out because I wanted to make sure that I didn't have to do a bunch of typing here. So we'll go to the first thing, which is, so this is a deployment. So in the YAML document, the first thing you'll see in all of these, you have to tell it what it is. So if it's a persistent volume, you have to tell it that's what kind is. So you can always see that when you're looking at these, and I'll have these posted out. You can see in here.
Hey, Adam, I don't think we're seeing that.
Oh, I thought it was on the screen over here. Let's see. So, oh, I bet I have to stop the presentation. That's probably what I didn't do. So end slideshow. There, now do you see it?
We're just seeing your putty session right now.
Okay, I'll try this again. So screen. How about now?
Yep.
Okay. So yeah, so you have a, it has a value of what it is. So you'll see kind and then the value. Lots of key value pairs in here nested within each other, arrays of different things. So you'll see that. So the first thing I want to do is I'm going to set up my secrets. So this is what a secret object looks like, just the kind. It has a name. The type is opaque. You can look at the doc. I'm not going to step through all of the different values, but opaque just lets me know that when it stores this, if anybody looks at the values in Kubernetes, they won't actually see the password values. They'll see an obfuscated version of what it is. So again, you can store it plain as well. Like you could store it in clear if you want. I don't know why you'd want a secret just so you could store it in clear, but they allow you. So for us, all I have to do is copy that out. And I'll move this over here. So the way the dashboard works is that to create objects, you have to be within the object area that you're trying to create it. So I would go to secrets, and then I would go up here and click the plus sign. And you're seeing this, right?
Yep. Sorry, I thought I was on mute. I was finding my screen back to get off of mute.
Yeah, so you just click the plus sign up here and then you paste it in. And then you click upload. And that's literally all it did. So I now have demo secret. This default token, that's just a default for the cluster. So we'll always see that. I didn't create that, but I did create this one, and it created it with the name that I had too. So that was the name. That's the name here. So it's very verbose. That's the biggest thing with doing Docker and doing Kubernetes is everything. You're treating operating system software like it's software, like it's a checked in piece of code. So so now I've created my secret. So now I want to go in and I want to create my persistent volumes so that I have resources for the cluster to use. So then I will go to persistent volumes and I'll click add. I'll paste that in. And like I said, all this does is it tells it where do I get these resources from? Again, the stuff that the storage admin would know. He's going to know the path, the actual physical path on the device, and he's going to know the type and storage class name, all the drivers that it has to use and everything. So all that's in here in this file. So for that, now I've created that. So if I go to persistent volumes, I now have my persistent volume created. And then I can go to persistent volume claim. And this is what the sysadmin is going to want, because they actually want to be able to have a resource that they can consume from the cluster. So this is going to have less information in it because it just has the name of the claim, and then it has the name of the volume that I get. And that's it. Like this, the class name is manual just because it's a manual process for the association. And then I specified that this is that I'm going to consume all 5 gigs of the volume that I have access to. I can put less. If I put more, it'll puke on me, telling me that the resource doesn't have as much, or it doesn't have as much resource as I'm trying to claim. But yeah, so if I'll go ahead and create this. So now I have a claim out here. So I have a claim, it's default, it's bound, because this claim is bound to this persistent volume. You'll notice, and it's purely my convention, but one of the things that I think as developers in general, people like to do is they come up with conventions, but it's even more helpful with Kubernetes because you associate things together. So like I call this Azure SQL 1 because it's the first one, it's demo because it's my demo. PD, this is a persistent volume, and then this is a claim. And if you notice, this is a persistent volume. And it's really helpful to have names on things that are meaningful and fit a scheme. So so there I've created my volume and my volume claim for what I'm going to be using. And then I want to create a service. And what this service does is, so node port is, you can think of it as a type of access method. So it's kind of like the difference between DHCP and static assigning. So node port, they have node port, and then they have I can't think of the other one that's really popular. But node port's really popular, and then there's another one that's really popular with like large clusters or enterprise clusters. But this one's kind of simple enough for a demo that I don't have to get into a whole bunch of details. But essentially, it's just doing, this is my external port, and this is the port internally that I'm mapping to. Because like I said, services, that's what they're used for, is giving access of internal resources externally. And then I use a selector, which is another concept that we probably won't get into in this, but it allows me to associate this service with an app, or what I would call a pod. So I will go ahead and get that added. So I go down to services and I will add that. So now if I look at services, there's my service right there. And like I said, there's this Kubernetes one is one that's there by default, again, because that's how it maps external resources to internal resources. So by default. The last step, and this is the step that actually is going to install the Azure SQL Edge. So in this one file it contains all of those parts, because I've declared all those parts and they're all out there and they exist, but this deployment actually ties them all together and tells them how they work together. So I specify the volume, so I create a volume object, and then I tell it that volume uses my persistent volume claim, and I give it the claim name, and it now knows that it's going to create a storage object with this claim, and now I have space. That volume is now something that I can access within my volume mounts within the container. So I now have access to that storage at these different mount points. So I have SQL data and SQL log, which obviously SQL people are familiar. The data is where the data is at, the logs are where the logs at. But now I can have multiple storage devices out there mapping where I want my logs to go or where I want my storage, my data to go. And that can all be mapped. And so this tells me the mount path is where it's going to mount that that storage inside the container. And the subpath is, if we go back into the volume here, so this is the path to that's on the physical device. This is the subdirectory within this path. So you would physically go to mount/storage01/SQL/log, and that's where the logs are. But physically in the container itself, this is where it's mapping to inside SQL, it maps to var op MySQL log, because those are in that's just it's another Docker concept, is that it's abstracting that away, because you could run multiple containers having different structures and different file systems. So you have to be aware of where it's mounting things to within the container, not just outside of the container. So the other thing it does here is, so it does keep track of that secret. So it references the secret that we created. So it has these are what are called, and it's in the environment. This is the environment variables section. So it has environment variables for accept EULA and SA password. There are others as well. If you look at the documentation, there's other things you can configure, but these are the ones I need. It assigns a container port of 1433, which that's where it uses this label for app name to map to my service that I have. So it maps 1433 to 31433. I keep forgetting where that's at. So that's how it maps the internal port to the external port, or to the service to the external port. And then the last part is the image. So this is the part that actually tells me where I'm going to download the Docker file from. So it downloads it from the Microsoft Docker repository, and then it looks for Azure SQL Edge for that specific Docker image in their repository. And when it spins this up, it's going to create the container, and the container is going to be named SQL1-demo. There are some other things down here. An image pull policy that gets back to when I spin up an instance of this Docker container. How often do you want me to pull down an image? I can always pull it down, or I can just pull it down if it's not present. And I choose not present, because if it's already there, I don't want to waste bandwidth trying to wait for the thing to download, just if it's already there. There's other theories where, if it's as far as pulling down, if you want to pull down an update, how do you go about that? And you wouldn't, the if not present doesn't work if you use a tagged image, but if you're always using latest, it'll always pull down. If a new version comes out, it'll always pull it out. It overrides the if not present and says, well, it's present, but it's old. Always will always do it, no matter if it's old or if it's new. It'll just always do it. Restart policy, that just tells Kubernetes that if the computer, if the Raspberry Pi, if it reboots, when Kubernetes comes up, do you want me to restart this container? And I always have it set to always, because I always want it to come right back up. But you can set other policies to say not to restart it automatically, to wait, and different things. DNS policy, this lets DNS try to resolve internally first, so that if I'm referencing a node name, it can reference that, or if I'm referencing a container or a Docker container that's running on another node, it will keep it within the cluster. And then if it doesn't get it in the cluster, so if I'm trying to hit Google, it'll then fail internally, but then we'll go to the host network and then go out my host network to get to the internet. And then the last thing here is enabling the host network so that it has the ability to access the host network. There's just slightly going to mention namespaces, because they can be important if you get into dividing out resources and organizing within your cluster where you want certain things at and how you want them to be able to talk to each other. I always use default, because I'm not that picky and sophisticated about how I'm deploying it, but you can deploy multiple namespaces to divide out to separate out clusters. So I will now copy that, go back over here and go to deployments, paste it in and upload. And now this actually gets into the work. So let me see if I can pull this up. So within the dashboard, it'll show you what it's doing while it's doing it. So these are the events. So it said it successfully assigned. It created this dynamically created pod using, obviously you can see it uses part of the name, and then it tags on a some sort of token to it. But so it successfully created that Docker container, and then now it's pulling an image, and it's pulling the image from Microsoft. And this will take a little bit to download it. It wasn't too bad when I did it earlier today, so hopefully it's not too overwhelmed. But yeah, so this will pull it down. But it also, looking at this at the pod, I can see other details. So I can see this is the IP address that it has. If I had a cluster, it would show me which node that it was installed on, the IP address of which node it's on, and it would give me the name of it. Gives me, just different conditions within the node. This is just the information for the master, and if it's got replicas, because you can, like, some of the failover capabilities within Kubernetes is that I can set up replicas. So if one goes down, it can instantly be there to catch up and take over, rather than having to wait for it to spin up and download an image and all this other stuff. It can just run them in parallel if you have everything set up correctly for that. And then it gives me the persistent volume claim, so I can see where it's what storage is available to it. And then it shows me in this container that I spun up, what are the attributes that it has. So it has the, I accepted the EULA, and then it has a secret, but like I said, it's obfuscated, so it won't show me what it is. And then I can see here that that's the image name for the Docker container itself. So. Did anybody have any questions while we got a little bit of time here?
So when you were pasting that YAML data, is it actually validating the YAML at that point in time, or is it just
does,
taking
yeah.
whatever?
So I could have shown that. So yeah, if you pull, like, if I take, I'll take my secrets, and I go back to the dashboard, and I go to secrets and click on add. If I take out that, it instantly goes up. It does not take it.
Well, at least it tells you what line it's on.
Yeah.
That's actually been the frustrating part when you're doing this in VI, and it's like, oh, how come this thing won't work?
And you can, and in here, like it says, you can put JSON or YAML. It'll take both. So if you like JSON, you can use that. You can also upload files or create it from a file, from a form. I've never used the form because, like, there's just so many things with environment variables and everything they have to add that it just kind of gets complicated to do it this way. But if you had a very simplistic image, like if you were doing like Hello World or some of the tutorials, it might be feasible. But I've used the create from file because I usually create files for this, but I've never done I've just never used the from form. But yeah. I was touched a little bit, replica sets and replication controllers. You can set that stuff up so that it'll do failover and things like that. I've never gotten into anything like that because I just do it for home use. So let me put this here. See how it's going. Oh, so it actually started. So it's ready to go. So now, like I said, so it successfully pulled the image. It created the container. And then it started the container. And so up here, and these are just two buttons you're going to want to be familiar with in here. This one shows you logs. And then this one will actually show you the console of the Docker, the running Docker container. So if I look here, this is literally everything that it did when it turned on. It shows all the verbose logging that you would normally see in the log. And it'll keep running. Like, it's not just the spin up, it's the entire logs as this sucker runs. So you keep going, it just keeps building. The other one, like I said, is the console. So this is literally a fully functioning console session to the MySQL instance that I spun up. So I can do anything I want within that container. And then, like I can go to var opt or MS SQL log, and there's my logs. I can go to data. There's my data, just like anything else that you think of. It runs whatever version, like the container specifies what kind of flavor of Linux it uses, but so in the bash and all that kind of stuff that it uses. So you'll have to get used to whatever they build it in. But I'm familiar with this one, so it wasn't that hard to figure out. But yeah, so you can see all of that there. And then just to go full circle with this, here's my management studio.
I was gonna say you gotta make a command connection
Oh,
to SQL, of course, right?
so now I'm going to connect to it. I put the wrong
That's your
password in.
password.
Oh, right, the port. What was it? 31.4.33.
Yeah, that sounds right.
And it might be a little sluggish because I noticed the last couple of times I've spun this up that like the first couple of times I log in, it runs kind of slow, but then it kind of catches up as it starts allocating resources and stuff to it. It's just for some reason initially it's very slow, but it'll connect. And I mean anything like any if SSMS can connect to it, anything can connect to it. But why is this not working?
Network.
The one thing I typed, 31.4.33, is that what I did? 31.4.33. And
Is that the right IP? Or you've probably been doing
it
multiple
was
ones.
190. Why is it not liking that? That's weird. Let's see, services. 31.4.33 maps to 14.33 pods. It's on 190. Looks like it's worked before. Well, that's disappointing. I didn't want to show a non-working node. Why wouldn't this be working? Unless it's just having trouble. Oh wait, it says parameters incorrect. Isn't that how you specify the port?
Yeah, it should be comma. Yeah. Do you got something set in your options maybe?
What do you mean?
The options tab?
Oh.
No, I don't see anything there either. I thought maybe you had encrypted or something.
Yeah, that's just disappointing. Because everything, I mean, it's obviously accessible because I can get to the dashboard and it's running on the same node as the dashboard. And it says it's up, and I've seen that it built the log files. Just another fun point. So like here's my NFS share, and there's my demo folder. Here's my SQL folder. I mean, here's the data files, the same ones I was showing you. They were all shows just created. Logs all show just created. So I mean, it's definitely there. Login failed.
Login failed.
Error.
I still wondered about that password. You were cut and pasting that, whether or not something's getting messed up when you cut and paste.
Yeah, let's look at that. It's a good thing to check out. So it's in my secrets. So that's there. Guess I can type it out. Let's try that. I think it would have logged in by now. Because even if it was slow, like even when it was slow, it would still it would log in, it just wouldn't populate the tree as quickly as I would have thought it would have. Ah, parameter is incorrect. I tried, I guess I technically already tried without that, but let's see. So if I look at my
Yeah, it's almost like it didn't build that service to expose the external.
yeah. Well, let me try, maybe I can just rebuild that. It looks like it's valid. Actually, I'll delete that. Still says unset. I don't know why. Unset. Man. Well, I don't know, guys. I may not be able to show this. I'm not sure why it's not showing. It's the curse of the demo, because I've shown, like, I've walked through this like 4 times just practicing it, showing like that it was accessible, that I could log into it, but for some reason it's not showing my service as available.
Yeah. Well, I believe you, and I've we've done it on our own stuff as well, just not on a Pi, and so it's kind of curious. I do have to drop though, so I do appreciate
Yeah.
all the time you put into this. Is great.
I was gonna say, so just before you go, because I just wanted to touch on just one more thing. So I did I put out the resources, so I'll have the slide deck out there, but I just had some links to the different places that I got. So the tutorials, the Microsoft Docs, the Docker Hub, and just like some of the stuff for Raspberry Pi and Micro K8s. I did have a page in here just talking about the differences between ARM 7, 64, HF, and AMD 64. And then some of the versioning, like the different distros that are supported, because you have to be very particular about what your images are made for their distros. So like I said, SQL Server on Linux only runs on these 3. So, and then technically they work on a Mac, but the Mac is kind of, it's different. So, but yeah, so you can, when you're looking at what to build and put in Kubernetes, make sure that you're aware of what distros that it's supported on. So. But
yeah, that's all great stuff. A lot of the details, is what you need to do to walk you through it, because it is not always as obvious to us Windows people how to do all those things.